I think it's working. Yay! Okay, so, I am jerky because my computer is running on high. My normal method of using my phone to record this with a system of clamps set up isn't working. So, we're trying my document camera, and it actually is okay. So, we'll see how this works. We're on our last one for this unit. It's evaluating expressions using order of operations, which hopefully you've heard of before. So, we'll go over them a little bit. But it's mostly just practicing what you already know and then adding in the negatives piece and remembering what exponents do and how negatives work with exponents. So remember, our expectations are that you're using twice the video and you're pausing. I'm hopefully going to pause and write some stuff and then hit play again to help save you time, save me some time. And yeah, so we should be good. We're going to have 6 examples at the top, and then we'll have 5 examples on the bottom. So there'll be 11 total, but they'll be short and sweet ones because it's just order of operations. So here's our after the video, making sure you're focusing, and away we go. Okay, so our new topic is order of operations, 19. We're not straight, are we? Wrong direction. There we go. That's a little straighter. Okay, so order of operations. And I'm going to need a new spiral for the next unit. I'm out of paper. Okay, so order of operations. Here is your learning target. All right, and I need markers because I didn't get those ready. Let's pick blue and red because why not? Okay, so we are going to have a refresher of what an exponent means and how we use it. So that's our first header, and then we'll go into order of operations and using all of them together. So here I'm going to pause. I'm going to write down our 6 examples. Pause. All right, so here are the 6 examples. If you want to write these down and try them on your own, go for it. We're going to do the first 3, and then I'll have you pause again, and you can do the last 3 on your own. So an exponent means how many times we're multiplying that number by itself, or together. So this is -2. Multiplied by another -2. Notice that this little exponent of a 2 we call a square, so this is -2 squared. So -2 is multiplied twice. There's 2 -2's there. So a negative times a negative makes a positive. Again, remember, I'm going to draw Mickey Mouse up here. We use Mickey Mouse for when we multiply and when we divide. There are 2 negatives, so if I cover up the 2 negatives, the sign left over will be positive. So this is going to be a positive 4. Now, the parentheses were really key in this example. This is parentheses. This is all-inclusive -2 multiplied by another all-inclusive -2. When you don't see parentheses, they're invisible. They're not imaginary. They are there. They're just invisible parentheses around only the number or the base. So the base in this case is 5. The exponent is 2. And then after I multiply 5 by 5, then I will stick a negative on the answer. So you're doing the base 5 times 5 first, because there are 2 5s, because the exponent is a 2, or a square. Then I will stick the negative on it, multiply it by that last -1. So 5 times 5 is 25, multiply it by -1, I get -25. And as you guessed it, if the exponent is a 2, you see the base 2 times. If the exponent is a 3, you see the base 3 times. So this last one should be -4 multiplied by another -4 multiplied by another -4. Notice that it's all inclusive. The -4 is multiplied by another -4, which is multiplied by another -4. So we're going to take this piece by piece. We're doing 2 at a time. So from left to right, that's really key today, is left to right. So what is -4 multiplied by another -4? This will make a positive 16. And now you can use your multiplication table. So what is 16 multiplied by a -4? Ignore the negative for now. 16 times 4 is 64. 64 with a negative on it makes a -64. Okay, pause here. Try these last 3 on your own. Then hit play and we'll go over them. So for number 4, you're multiplying -3 by another -3. You should have a positive 9. Moving this up. Then 5 there's a negative at the end, you're doing 7 times 7 first because that's the base. Remember, there are invisible parentheses around that base of 7. So 7 squared, 7 times 7 is 49. Stick on a negative, you get negative 49. On 6 or exponent change, this is called a cube. So this is 7 squared times negative 1. This is 6 cubed times negative 1. So again, I have that negative 1 on the outside, but how many 6's are on the inside? 3. 6 times 6 times 6. 6 times 6 itself is 36. Multiply by another 6. You're going to have to do some math on this one. So think about what's 6 times 3. So that's 18. That makes 180. And then what is 6 times 6? 36. What is 180 plus 36? 216. So this is going to make a negative 216 because we can't forget that negative on the outside. We do that last. Just stick that negative on there. Awesome. So that is exponents. Now we're going to switch into the actual body of everything, and we're going to use order of operations. We'll do an intro one, and then we'll do 4 examples of actually evaluating expressions and what that actually means, because those are 2 really big words you're going to hear a lot. Okay, so order of operations. Okay, moving this up. So I need to have enough room for 5 examples on the bottom. So we're going to have, yeah, let's do it that way. We're going to have a P for parentheses, E for exponents. I'm going to do M, D, A, S. Then we'll have 1 example over here. Okay, so writing this down, this is the order of operations. So we always start with parentheses, then we go to exponents, then we do multiplication and division, then we do addition and subtraction. So notice that we're starting at the top. You've probably heard this before, Pemdas, because we spell P-E-M-D-A-S. It's not a word, it's an acronym that stands for parentheses, exponents, multiplication, division, addition, and subtraction. When you do multiplication and division, you do them at the exact same time. But now the question is, what order do you do them in? Because we all want to have the same exact answer, that's our goal, is to have the same answer as everyone else in the world, we go from left to right. From left to right. Same thing with addition and subtraction. We've done keep, change, opposite that changes subtraction problems into addition problems. So really, they're kind of the same thing. You can make them look like each other. So we're going to do them from left to right at the same time. So making sure that we go from parentheses, exponents, then we do multiplication and division from left to right at the same time, addition and subtraction, same time from left to right. So an example is 6 divided by 2, 1 plus 2. I can't remember if we did this as our warm-up already or not, but it's a common question you see online, especially on Facebook, of what answer do you get? So pause the video, think about if you didn't have an order of operations and you could just do any math in any order, what number would you get as your answer? And then if you use the order, what answer would you get? So pause the video right now. Okay. If I do the order of operations, I'm going to start with what's inside parentheses first. So inside I see a 1 plus 2. So my first step is to keep the 6 divided by 2, and I add 1 plus 2, which gets me 3. Parentheses are done. Check. Next one, exponents. Do you see any exponents? A square, a cube, a quartic, to the quintic, to the 5th, the 6th power? Nope. Okay. There's none, so let's skip it. Multiplication and division. Do you see some multiplication? Do you see some addition? Or division, sorry. Multiplication and division. If so, we're going to do them from left to right. So starting here, I see the 6 divided by 2 first. What is 6 divided by 2? 3. Now I see the multiplication. What's 3 times 3? 9. So your final answer should be 9. If you did them in a different order, you'd get a different answer because we all want to make sure our math is the same, because otherwise we don't want a bridge. I think the bridge is 6 feet. You think the bridge is 7 feet. my material's not going to make it, or your material's going to overshoot it, and then the cars will all fall off, or it'll be the wrong angle, or we'll have too much extra expense because we had to buy so much more material than we really needed. So our math and numbers have to agree. So we have to make sure we use the same order. Imagine that. Okay, then we have 4 examples. So box it off as 4 for the end of our thing, and I'm going to pause, and then you can write down stuff. All right, pause the video, write these down. So evaluate means to solve or simplify, to make this whole thing, this ugly looking thing with a bunch of variables that are just like, I don't know what this means, get it down to as small as possible. In this case, it'll be 1 number. So our answer to all 4 of these will be 1 number. That's what it means to evaluate. The expression is what's given. This is not an equation because there's no equal sign. Equations have to have equal signs because they're equations with equal signs. Because there's no equal sign, this is just an expression. So I'm going to evaluate or simplify this expression. And I'm going to replace what I know. I don't know what x represents. Oh wait, do I? X equals -6. So this is an equation. X is the exact, it's a placeholder for -6. So I'm going to replace x with the -6. Z, I'm going to subtract, z is the same as -3. Y is the same as 2. Notice I'm replacing each of the variables or substituting with parentheses and the number that it equals. Parentheses are really helpful to make sure you keep track of signs. Okay, if you forget the parentheses around this z, most likely you will keep it as a -3 instead of making it a positive. So notice we're going to go addition, and there's no there are parentheses, but there's only 1 number inside the parentheses, so we're good. Are there any exponents? No. Multiplication and division? No. Addition and subtraction? Yes. And we go from left to right. So starting with just these first 2, this is a subtraction problem. So I'm going to keep, change, opposite. I'm going to keep the -6. I'm going to change this to addition, and the opposite of -3 is +3. What is -6 plus 3? -3. Then I bring down the +2. Again, I see addition and subtraction. So let's do that. What's -3 plus 2? -1. Pause here. Can you explain every single step of what we did and why we did it? Okay, the next example. A squared plus B minus C. Pause the video, replace the values where they should go. You should end up with -4 squared plus 6 minus a -3. If yours looks the same, awesome, keep playing. If not, pause and fix it. Parentheses. We're good. They're all 1 number inside the parentheses, so we're dandy. Next one, exponents. I see one, -4 squared. That means -4 multiplied by another -4. What is -4 multiplied by -4? You should have +16 plus 6 minus a -3. All right, I don't see any multiplication and division. I do see some addition and subtraction. Again, from left to right. Covering these last one, so just the first 2. What is 16 plus 6? 22 minus a -3. Again, I see addition and subtraction from left to right. They're the only 2 left. It's subtraction, so I'm going to keep, change, opposite. I'm going to keep the 22, change this to addition. The opposite of -3 is +3. So 22 plus 3 is 25. All right, for the last 2, we're going to reintroduce absolute values. Those are the bars. Remember, there are 2 buttons above your shift key. And now the A and the B will be the exact same for both of these questions. So, random FYI. Looking at this, I need to replace. So I have the absolute value of -30 minus the absolute value of -4. Keeping those bars straight. These are not parentheses, they are bars, and they mean the absolute value or the distance from 0. So looking at that, when I look at parentheses, those are similar to absolute value. Some people call the parentheses instead grouping symbols. That includes absolute value, that includes brackets, that includes fractions, so the numerator versus denominator, they're being grouped into the top or the bottom of a fraction. So, looking at that, let's do those grouping symbols first. How far from 0 is negative 30? 30. How far from 0 is negative 4? Positive 4. And now I don't see any exponents, I don't see any multiplication or division, but I do see some addition and subtraction. Again, from left to right, what is 30? Keep, change, opposite, plus a negative 4. You should end up with 26. All right, try the last one on your own. Notice that this is multiplication. Pause the video. Okay, so you should have 30 times the absolute value of negative 9. This is a grouping symbol, so the absolute value of negative 9 is a positive 9. Notice that I changed it to a positive 9 and now it's in parentheses. I've evaluated or figured out and simplified the absolute value. So I'm down to just parentheses of positive 9. Multiplication's next. 30 times 9 is 270. Now I have subtraction. 270 minus 40 would be 230. And we're good to go. Woohoo! All right, and PowerPoint. Were you focused? How many times did you pause the video? Could you explain the order of operations to a friend or your parent or your younger sibling or your older sibling or your dog or your pet or a lizard? Could you explain how this works and why we need it? Those are 2 key questions. All right, have a great day and bye.